Our first lesson in Unit 3 on transformations deals with reflections. You saw everything we're going to talk about in this unit back in Math 7 and Math 8. You did transformations in both of those grade levels, turns, flips, slides. You even did dilations where you enlarge something or reduce something in size. You talked about lines of symmetry. There's just a few little details that you didn't talk about in middle school. This unit's going to go by very quickly, and let's start with reflections. So, how do I reflect an object? Okay, so our first vocabulary word is actually going to be transformation. Our unit is entitled Transformations, so it's a good idea to know what the unit title means. And a transformation is an operation that maps the original figure, called the pre-image, onto a new figure called the image. Two important vocabularies. So pre-image is the original and image is the new one. A transformation can change the size, the position, or the shape of a figure. Okay, prime notation. When we're drawing our figures, especially on the coordinate plane, we need a way to indicate between the original and the new one. So we make that differentiation using prime notation. The pre-image, your original, is labeled with capital letters. At every vertex, every corner. The first image is labeled with capital letters and a prime at each vertex. So for example, A prime. It almost looks like a slanted tick mark. Okay. The second image is labeled with capital letters and double primes. For example, A double prime. This pattern continues. There's technically no limit to how many primes you could have. We generally stick with 2 in geometry, but you can have 8, 9, 12 different transformations going on to the same shape. Of course, it would get really messy, but you could, in theory, do it. Let's talk about an isometry. Isometry, that's an interesting word. I like the way it sounds. Okay, but another note card for you. An isometry is a transformation that does not change the size. So let's think about what you learned to do in middle school that doesn't change the size. That would include translating, sliding, rotating, turning, and reflecting or flipping. The one that doesn't keep the size the same is dilation. All right, now that we've got some basic vocabulary out of the way, let's get to the meat of today's lesson and let's talk about reflection. All right, yet another vocabulary word. A reflection is a flip over a line of symmetry. each point and its image are the same distance from the line of reflection. So in middle school, you stuck with reflecting across the x-axis or the y-axis. To take it just a step further, now that you're in high school, we're going to add in lines with a slope of +1, like y equals x, and lines with a slope of -1, like y equals -x. Okay, if your teacher pushed you a little bit in middle school, you did vertical lines like x equals a number, x equals 2, and horizontal lines, y equals a number, y equals -2. So let's practice some of these. We're going to graph and label each figure and the image under the reflection and then name the new coordinates. Triangle ABC. So A is at -4, 2. B is at 4, 7. And C is at 5, 1. So now I'm going to A, B, C. Okay, next they ask me to reflect in the x-axis. So this is my x, horizontal, y is vertical. I always sketch in a dashed line on my line of reflection. Okay, and now I am literally going to count. This is nice and beautiful on the grid. So C is 1 unit above. If I go 1 unit below, that will be C prime. B is 1, 2, 3, 4, 5, 6, 7 units above. 1, 2, 3, 4, 5, 6, 7 units below B prime. A is 2 units above. Go 2 units below and you have A prime. Draw your triangle. And now list your ordered pairs. -4, -2. 4, -7. And 5, -1. All right, I want you to try number 2 on your own. Remember that reflecting in the y-axis means you're going to be reflecting across this line. Pause the video, try the problem, and come back and check. Okay, check your work. If you need to pause the video again in order to check everything carefully, please do so. But all I did was count horizontally. For example, R was 8 units to the right of my line of reflection, so I had to go 8 units to the left to find R prime. Okay, I am going to ask you in a minute to pause this video. What I want to take a moment and make sure you know is how to graph x equals 4. If I go to the x equals 4 on the coordinate grid, this is a vertical line through x equals 4. So pause your video and graph this reflection. All right, take a minute to check your work. If you need to, pause the video to make sure you have done everything correctly. Right, but for example, K was 2 to the left of my line of reflection, so I had to go 2 units to the right of my line of reflection. When these are all horizontal and vertical flips, it's just a matter of counting on the coordinate plane. Now let's try it where y equals -5. And this time, before I pause the video, I'm not going to show you where that line is. I will remind you it is horizontal. Pause your video and draw this reflection. All right, take a minute to check your work. Pause the video if you need to. All right, n is at -1, -4. Okay, again, we're counting straight on the coordinate grid when they're horizontal and vertical. The next two are a lot more interesting. We're asked to reflect a rectangle in the line y equals x. That means I have a y-intercept of 0 and a slope of 1. I suggest you use a straight edge to draw in that line. Now remember, our definition of a reflection is that we are going to be equal distance. Equidistance has to be perpendicular. So first let's graph PQRS. 7, negative 1, 7, negative 4, and 2, negative 4. Okay. P, Q, R, S. All right. So when I count, right, the lines I'm counting on have to be perpendicular. Perpendicular to positive 1 is negative 1. So what I usually do is start at the vertex and sketch in my negative slope. Okay, I went 1.5 on the diagonal. So half and 1 on the diagonal will give me, and I'm going to do it in blue, P prime. P prime is at negative 1, 2. Let's look at Q. I'm going to sketch in a line with a slope of negative 1. Now I'm going to count 1, 2, 3, 4 diagonals. 1, 2, 3, 4 diagonals. And there is Q prime. So PQ. Let's do R. Sketching in that line with a diagonal of negative 1, slope of negative 1, sorry. 1, 2, 3, 4, 5.5 diagonals. Half, 1, 2, 3, 4, 5. Let me make that blue. There's R prime. R prime is at negative 4, 7. And Q was at negative 1, 7. Last up, S had better wind up right here or we won't have a rectangle, right? Let's see what actually happens. Make that blue so we can see it. Okay. Sketch a line with a slope of negative 1. And I'm 1, 2, 3 diagonals, 1, 2, 3 diagonals. It worked. It worked, it worked, it worked. So S prime is at negative 4, 2. And now I can draw in my rectangle, and I've done it. Really, really helps to use a straight edge as you're doing these. Let's try another one. This one, our line of reflection, has a slope of negative 1. Use a straight edge, ladies and gentlemen. If you don't, you will regret it. Let's graph this triangle. Negative 1, negative 6, 0, negative 3, 3, negative 4. Label it J, K, L. All right, so I am reflecting with a slope of negative 1, so I need to sketch in lines that have a slope of positive 1. Doing L first. L is half a unit away, so L prime needs to be half a unit away. Let's sketch in K. K is 1.5, so I go half and 1. There's K prime. And let's sketch in J. J is 1, 2, 3.5. Half, 1, 2, 3. There we go. So let's see. J prime is at 6, 1. K prime is at 3, 0. And L prime is at 4, negative 3. All right, so for your summary, you want to write a couple of sentences about how you reflect. Be sure you include information about how you reflect across the harder lines, y equals x and y equals negative x.